Hello, this is Susan Poss. I'm still working in section 10.5, working with parabolas, maximum and minimum points, which is equivalent to the vertex of the parabola. And this is the last word problem. This one has to do with an object that's fired or tossed or thrown, and we're looking to see what its maximum height, how high will it actually go when it peaks out. So I've got a formula here. And H in this case stands for the height of the object as it moves along the path, the trajectory. T stands for time. In this case, it's time in seconds. V sub 0 is an initial velocity or a starting velocity, and that's a very common notation. When you see a subscript of 0, it means the starting velocity, or for H sub 0, the starting height, the release point. And I've gone ahead and written down here the formula that we were using for finding the coordinates of the vertex. All right, so this looks pretty intimidating right at first, but let's read it and let's talk about this formula, and once we make the substitutions, I think it'll be fairly simple to work. So it says use the function h for height equals negative 16t squared, t is in seconds, plus v sub 0 t plus h sub 0, where h is the height after time t, v sub 0 is the initial velocity, and h sub 0 is the initial height. So if someone's tossing a ball vertically upward from the ground, that is important, from the ground, with an initial velocity of 112 feet per second. When will the ball reach its maximum height? When? When is time. So we're being asked to find out something here about time. When will it reach that maximum height? And then here on the second part, we're asked to find out what that maximum height is. So how high will it actually go? All right, so the first thing we have to do is substitute the numbers in the proper places. So h, this negative 16 is a gravitational force pulling the object back to Earth. Since we're in feet per second, there's a different number if you're in meters per second. All right, so v sub 0, initial velocity. V sub 0 is an initial velocity. If I look right back up here, it tells me that the initial velocity is 112 feet per second. So replacing v sub 0 with 112. And then h sub 0 is the starting height, the release point when in this case, the ball is thrown. And remember, I highlighted from the ground. So we're going to assume it really wouldn't quite be 0, depending on your height. It might be 3 feet above the ground when you let go of it, but for this case, we're going to go with 0. And now all we need to do is find the vertex, because the vertex will be written in terms of t and in terms of h. So this first number, when we get it, is going to be in terms of seconds, and the second number, when we get it, is going to be in terms of feet. All right, so let me do the work. X in this case is t. Negative b over twice a, which is negative 112 over twice negative 16. And let me pick up my calculator and divide that out. That's 112 divided by 32, and that is, oops, I typed that in wrong. 112 divided by 32, type 35, is 3.5, and remember this is in seconds. So it's going to take 3.5 seconds for this object to reach its maximum height. And then we're going back and we're looking for y, the y coordinate, which in this example is h. And remember, we just take the original function, we plug in with the value that we found for the x-coordinate of the vertex. And let me do a little work here. So this is negative 16. Remember, I have to do the squaring first. So 3.5 squared is 12.25. And 112 times 3.5 is 392. And 12.25 times negative 16, again that gravitational force is negative 196. And when I combine those two, I get 196, which is in feet. Well, there goes my kitty cat again. He's jealous. He wants me to pay attention to him. All right, so what we've done here is we've answered the question. When does it reach its maximum height? It reaches its maximum height at 3.5 seconds. And at that point in time, how high is it? It's 196 feet high. So I hope that will help you with problems where we're tossing or firing an object and trying to see how long it takes to get to the maximum height and what the maximum height is.